Hi. In this video, we'll talk about ways to build fact fluency. In earlier videos, we focused on counting up and back. We focused on counting to know how many. And then we focused on working with different kinds of number models. But today, we're going to move on to starting to build fact fluency. Math has changed in a lot of ways since you and I were in grade school. But one thing that has not changed is that we want all kids to know their basic facts without having to count. The emphasis, though, has shifted from just memorizing facts to using strategies and understanding how the facts work. Let me give you an example of that. So we want our kids to learn strategies that will take them beyond the basic facts. We want them to be comfortable with putting numbers together and taking them apart in smart ways. So here's an example. If you've memorized 9 plus 6, that's great. It's 15. Many kids memorize it, but many struggle with remembering all the facts. So then they resort to counting, hopefully at least knowing to start with the 9 and count on 6 more. They can still be successful in math, but it will take them longer to solve a problem. And as the numbers get larger and the problems become more complex, not knowing the facts makes everything more difficult. But if you know more about how numbers work, you understand that 9 and 6 is the same as 10 and 5, which is an easier fact for kids to know. Knowing that strategy, that I can break apart the 6, make a 10, and rename it, can take me into higher problems like 29 and 16. This can be thought of as 1 and 15. The 29 can go with the 1 to make 30, and there gives me a sum of 45. So you might look at this and think, well, that takes a lot longer. What's wrong with the way that we learned it in school, where we had 29, 16, carry the 1, and get the same sum? Well, this is quicker when you look at it written. But when kids learn strategies, what actually happens with a problem like that is they just look at it and mentally rename it without actually doing anything in writing, and then come up with 45. So this is actually quicker, and it can be done without pencil and paper. That's an example of how we can use strategies as we're learning the basic facts and then take them into problems that have higher numbers. So let's begin by looking at the facts to be learned. This chart shows the 121 addition facts that a child is supposed to master by the end of second grade. To use the chart, you would find a number at the top of a column, a number on the side with your other hand. Here I have 7 and 5. Follow the path until the 2 meet, and we have 12. So 7 and 5 is 12. Another example, if I'm looking for 4 plus 8, follow the 4 down, follow the 8 across, and I see that the sum is 12. So a chart like this can be used to do simple addition, but it's more important that it be used as a tool to notice the patterns and the relationships between the numbers. One of the things that you can discover by looking at the patterns on the table is that the order of the numbers when you're adding does not change the answer or the sum. So I can see that 6 plus 3 is 9. Can also be found 3 plus 6 is 9. In fact, all of the facts are on the table in the reverse order. The only ones that don't show up twice are what we call the doubles, the ones that are the result of adding numbers like 4 and 4, or 3 and 3, or 8 and 8. So this chart highlights those doubles on the diagonal. Every other addition fact repeats. What's up here is mirrored down here. So once your child understands that, you can change the order of the addends and still get the same answer. That job of learning all these facts is cut in half. So let's take a look at that. It's often called turnaround facts. The formal name for it is a commutative property, and that is the idea that it doesn't matter which addend you start with, you get the same sum. So here are some ways you can help your child understand that turnaround or commutative property. If we're working with something like this, here I have some counters that are stuck together. I have 7 red and 4 white. That's 11. Whether your child counts them or not, I'm not worried about right now. What the point is here is that 7 and 4 is exactly the same as 4 and 7. It doesn't matter which ones you count first. If you don't have counters like this, that's fine. You can do the same thing with any kind of counters. Here we have pennies. So we have 5 and 2. I can count 5, 6, 7, or I can start with the 2. Either way, whichever one I start with, I'll get the same sum. A domino also illustrates this quite well. Here's a domino that shows 4 and 5, or a total of 9. But if I turn it around the other way, it's still 9. It's just 5 and 4. So that turnaround property or commutative property really helps your child when they're trying to learn all the facts because it cuts the work down considerably. You can do it on the rec and rec as well. If I have 4 and 2, that gives me 6. That's the same as if I start with the 2 and add 4 more. I get the exact same sum. That's the commutative property. Another thing that would make learning all these facts much easier for your child is if you can get to the point where he or she can count on adding 0 or 1 or 2 to a number without having to count, just knowing what the answer is. So here's our addition table. Let's take a look at the one for kindergarten. The facts that are highlighted in blue are the ones that we want our kids by the end of kindergarten to know without counting. All of these can be found if a child understands how to add 0, 1, or 2 to a number. In first grade, the facts go up to 10 now. But again, many of these can be learned by just adding 0, 1, or 2 to a number. In fact, in first grade, there are only 15 new facts to learn after kindergarten. By the end of second grade, we're back to all the facts again. But the work is cut down considerably if they know how to add 0, 1, or 2. It takes care of quite a few. One more thing that will help a lot is to help your child understand that addition and subtraction are opposite or inverse operations. Adding is about putting things together. Subtracting is about taking things apart. So, for example, if you have 6 pennies and you put 2 more out, now you have 8. You can do things like this in the context of a story problem, like 6 kids were on the playground. 2 more kids came. How many are there now? But then reverse the action. 2 kids left the playground. Now how many are there? So your child gets to see that 6 and 2 is 8 together, and we can separate it back into it's 6 and 2. That subtracting is the opposite of adding. Another thing you might have seen your child working on, or something you can work on at home, is the idea of a family of facts. So I'll use this domino to help me. If I put the dots on each side together, I can get this problem, 5 and 4. That's 9. If I flip the domino around, that gives me 4 and 5, still 9. If I start with the total, 9, and cover up part of it, I still have 5 left. If I start with 9 and cover up the other part of it, I still have 4 left. So all of these facts together are sometimes called a family of facts, and they show how when you put numbers together, you can also take them apart. Understanding this will help when your child gets to learning subtraction facts. Because if they know their addition facts well, the subtraction facts aren't really something brand new. Say you have this problem, and your child knows that fact. When faced with something like this, your child can think, well, 7 plus what would get me up to 9? So we're going to practice every chance we get to connect addition with subtraction, and that'll help a lot. So as you're working on the facts, don't get overwhelmed by the sheer number of facts. Find ways to make the job easier, work smarter, not harder. So wrapping up, in this section we've talked about ways to work smarter, not harder, to learn all the addition facts. We talked about the turnaround property. We talked about mentally being able to add 0, 1, or 2 to a number. We talked about connecting, adding, and subtracting. However, whatever grade your child is in, I recommend that you tackle learning the facts in small sets and work on strategies for several reasons. First of all, it certainly makes the task easier, makes it more manageable. Looking at 121 facts may seem like an impossible task for your child. Second, the strategies that we use will extend beyond the basic facts. And finally, and probably most importantly, if your child learns these facts with understanding, then he or she is also building confidence, using reasoning, and learning that math makes sense. If you need any of the materials that you saw in this video to work with your child, please contact Dr. Sarah Lee at slee@k12.wv.us. Thank you.